OK, so the rest of today is more about breaking down different ways that DoS attacks can happen and also where they can happen. So we'll split up the attacks across two different axes. One axis is how the attack happens, and the second axis is where the attack happens. Will probably make more sense once we show you both of them. So here, we're categorizing attacks into one of two different categories. Some DoS attacks have to do with exploiting the program itself. In other words, we're crashing the program by exploiting a bug in the program. So some possible examples. Maybe the program has a buffer overflow, so we exploit the buffer overflow. We run some shell code that shuts down the system, and now the system is down. We achieve this by exploiting something that was wrong with the program. Or maybe the program is vulnerable to SQL injection, so we'll inject a SQL query that deletes the whole database, and now nobody can use the service because all the data is gone. So these are problems with the program itself. And the defenses are just like all the defenses against software vulnerabilities that we've seen. Use a memory-safe language, defend against SQL injection attacks with escaping, all of the usual stuff. So if your system can be hacked, someone can do a denial of service by step 1, hacking into your system, step 2, crashing your system on purpose. And the way to stop it is to make your service harder to hack into using all the defenses we've talked about. That's basically all we're going to say about that section because it's similar to all the other attacks we've already seen where people hack into our system. The only difference is now, instead of stealing our secrets or running code, they just want to crash our system after hacking into it. That's one possible strategy. Now, a totally different category of strategies for denial of service has nothing to do with hacking into our system and have more to do with resource exhaustion. Every system that we ever build has limited resources. There are limits to how much compute you have, how much network bandwidth you have, how much time you have to run the service. Everything has limited resources. So if an attacker is able to consume all of the resources that you have, then you are out of resources, and legitimate users cannot access your website because you're busy serving the attacker who is wasting all of your time or your resources. Now, this is very different from hacking into your system. The attacker isn't trying to break into your system at all. They're just exploiting the fact that your system has limited resources. Most people, when they think about denial of service, they're probably thinking about the second point. But don't forget that this first strategy also exists, where someone hacks into your system and then crashes it once they have control. But we'll focus most of our time on this second point, since it's different from what we've seen so far. So if someone wants to use the second strategy, where they exhaust all of your resources, they might do so by targeting your bottleneck. So maybe that's a term you've heard from other systems design topics. But the bottleneck is the part of your system with the fewest resources. So if you have a system, it might have a lot of different components. Maybe you have a database, and you have a server that's computing things, and you have a network router that's sending and receiving data. Some of these systems might be high capacity. Others might be lower capacity. And the attacker only has to take down the weakest link, the component with the lowest capacity, in order to take down the whole system. So you could have a very high-powered database and a high-powered router. But if your server compute power is weak and the attacker exhausts the compute power, it doesn't matter if your database was huge or your network connection was great. Your service is still down because all of your CPU compute power is gone. So when you're designing systems and you want to protect against denial of service, you have to think carefully about where your bottleneck is. An attacker only has to take down that weakest link. It doesn't matter if everything else is strong. Your whole system would still go down.